So we have one last section here in factoring. It's a long section. This is called completely factoring. And what that means, it's actually, the last example we did, 26, was completely factoring. Because what happens is sometimes you need to factor twice. You might need to factor a greatest common factor and then go from there. So we'll do a couple more examples here. 27. I notice two terms and I notice we have a minus. So I'm thinking, hey, maybe this is a difference of two squares. The problem with that is that these are not perfect. So your first move is always to try for a GCF. Always do that first. Well, both of these 2 and 32 are divisible by 2. X to the third and x to the first, we can factor out an x as well. So let's pull out 2x. And what we'll be left with, that will be x squared minus 16. Okay, now before you stop and move on to the next one, look at what's left in the parentheses. Can you factor that? And in this case, hey, this is a difference of two squares. That's x times x, 4 times 4. There's subtraction. So we can immediately go to our two binomial factors, x plus 4, x minus 4, and this, don't forget the 2x that you pulled out. That is completely factored. You're done when you cannot factor anything more out of the parentheses. Number 28. Each of these is divisible by 5, so we'll factor that out. That's our GCF. That would give us 1x squared. Divide there, that's minus 5x. Divide there, that's minus 6. Okay, look at the trinomial inside. So we're thinking that's a 1x squared, so what multiplies to the constant, negative 6, and adds up to the b value, negative 5, the middle. Now 6 only has two factors, 1, 6, 2, 3. Now be careful because it has to multiply to a negative, so it's got to be plus minus. It has to add up to negative 5. 2 and 3 is no good because if you do negative 2, negative 3, it adds up to negative 5, but it doesn't multiply to a negative. It multiplies to positive 6. So what we have to do here is plus 1 and minus 6. Okay, so let's see, let me come down here. Our two binomial factors, x plus 1 times x minus 6. Don't forget, though, that we had already factored out the 5. That is completely factored. All right, one more here. Well, they all have an x. 6, 27, 21. They're all divisible by 3. So 3x. Divide that, that would be 2x squared. 6 divided by 3 is 2. This would be 9x. This would be 7. All right, now we have a trinomial, but notice that the a is not 1. So to do this, we have to think what multiplies to AC and adds up to b. 2 times 7 is 14. And what adds up to the middle term, 9. Oh, there you go, 2 and 7. Okay, we see that. That's pretty good. Okay, now you got two choices. You can either do grouping or you can do the box method. I'm going to do grouping this time. For now, I'm ignoring the 3x. Okay, I know that at the end I'll have to put it on, but for now I'm just going to do this. So we're going to, for grouping, we just copy 2x squared. Instead of 9x, we'll write that as plus 2x plus 7x. That's your middle term. And then the constant 7 stays the same. Okay, now to group, look at the first pair of terms. Well, both of those are divisible by 2x. We pull that out. Now that just leaves us 1x. 2x divided by 2x is not 0, that's 1. Anything divided by itself is 1. How about the second pair? Each of those is divisible by 7, so we go plus 7, factor that out. We get x plus 1, that's good. Since both expressions have the same binomial factor, we're going to factor that out. So x plus 1, we take that out. What's left? 2x plus 7. And don't forget, we originally factored out 3x. Now that is completely factored, and that is the end of the notes.